December 12th, 2016. I'm on a page on my laptop here. I'll link it to the bottom. I keep forgetting to do that. It's Science Alert. It's written May 24th, 2016. The title of it is Earth's core is 2.5 years younger than its crust. New calculations reveal. I'll read it out and I'll go ahead and critique each paragraph as it comes along, so that way it's easier to remember. If it sounds impossible to you that the surface of our planet is actually older than its inner core, prepare to have your mind blown, because according to new calculations, the inside of the Earth is actually 2.5 years younger than the outside. And before we get into this, you have to realize that they're ignoring everything. They're just talking about general relativity. They're not talking about melting down iron. They're not talking about physical vapor deposition during earlier stages of the star's evolution. They're not even really mentioning how something can form that massive in the central regions to begin with. They're just talking about general relativity. How is that even possible? Well, it all comes down to the effects of gravity on our planet as predicted by Einstein's theory of general relativity. Yep, that little equation that follows us everywhere we go states that our position in the gravitational field, aka our space, regulates the rate at which time passes for us, and in the 4.5 billion years since the Earth first formed, time has been moving more slowly in the core than on the surface. To me, that's absolutely ridiculous. The preposition that they're showing here is that the core and the surface of the Earth, when the Earth formed at the same time. But as we all know, whoever's seen the theory that I've been developing, the core forms way before the crust does. The crust is like a thin, insignificant layer that just happened to be there as the atmosphere was dissipated and just left over this little rocky, thin surface. But before any of that could have happened, you had to have built the central regions first. You have to build the foundation to the house before you build the roof. But they don't do that in these theories that they draw up. They ignore all the facts, they ignore all the physical processes, and they take large-scale structure, which they think is the core, which they think is the crust, and they compare the two, and then they make these wild assertions based off of these pseudoscientific theories, and then all of a sudden you end up with this. The inside of the Earth is 2.5 years younger than the outside? How does that even make any sense? A year is something that the Earth goes around the sun. That's a year. So how is the core and the crust, which go around the sun the same fucking time, different ages? See, they want you to accept that bullshit. They want you to think that that's what science is. It's not. That's just them making up a bunch of fantasy bullshit. Okay, here, next paragraph, sorry. In something theoretical physicist Richard Feynman predicted back in the 1960s, reportedly saying in a series of lectures that the curvature of space-time should, in theory, put an age gap between the Earth's center and surface of a day or two. Since then, this fact has been cited in numerous papers by other physicists and even university textbooks. But no one has ever bothered to investigate if Feynman's estimate was actually true. Enter physicist Ulrich Ugaro from Aarhus University in Denmark, who himself admits to citing Feynman's famous speculation in previous papers before coming to the realization that no study had gone to the effort of confirming the numbers. One should always be cautious, this is his quote, one should always be cautious and test even famous people's suggestions. He told Jacob Aron at New Scientist, I fell into the trap of not doing it, I must admit. And that's the most important thing out of this whole article. It's not whether general relativity can prove that the Earth's core is younger or older. That's just a bunch of airy bullshit. What he was really getting at is that they had this famous guy say something to be true, and nobody questioned it. They just all accepted it. They just published the results because he said it. And that's a major trap that a lot of physicists are falling into these days. They think that because somebody was famous, because everybody knows it to be true, that it has to be true. That that famous person, his theories, his ideas, his mind, his rationality are completely unquestionable and infallible. And that's what I'm falling into myself. If you have somebody, even myself, if you have somebody out there that is stating this argument from authority, from an authority figure, never forget that you can question them. You can say, hey, I don't think that's necessarily true. I don't think that that's how it works. You can do that. It's not going to be good for you career-wise because you'll be an outcast. But in your private life, in your work, you can always do that. You can always write papers up showing how all of it's wrong. But on the surface, I guess you could just go along with the crowd. That's if you want to do that. Me, I don't really give a shit what the crowd thinks. But basically, that's what it really amounts to, is that they took a supposed great theory, and they're applying it to places that should never been applied. You should have always been doing just basic physics with this. The core of the Earth is literally, what, a trillion? I did a calculation one time. It's like 1 trillion cubic kilometers. 1 trillion cubic kilometers of solid iron and nickel. How the hell does that thing get to the center of the Earth? It had to have taken something extremely hot and violent to melt all that iron down, or at least a physical vapor deposited during earlier gas stages of star evolution to the center of the Earth, and it collected there over time, over many billions of years. The core, if anything, is billions of years older than the crust. The crust is just a temporary, oh, it just formed and life just started, walking around on it. It's a very, very young structure compared to the core of the Earth. But, you wouldn't really know that if you had taken these articles to heart. Alright, y'all. I think that really sums up today's talk. Later.